Welcome to the video on prompt engineering versus RAG versus fine-tuning. These are one of the most important concepts which is used in the modern AI applications. These terms sounds technical at first, but once you understand what each one actually does, the difference becomes very simple. So guys, if you want to learn about it, then watch this video till the end. In this video, we will see how prompt engineering helps us improve the way we ask the model, how RAG helps the model answer using external documents and real data, and also guys, how fine-tuning helps the model become more specialized for a particular task or style. Along with this concept, we'll also look at simple project structures and some practical examples which is going to give you better clarity about these terms. Now, here's the agenda of our today's session. First, we are going to start with an introduction to prompt engineering, RAG, and fine-tuning. And after that, we are going to deep dive into what exactly is prompt engineering, what is RAG, and what is fine-tuning. Then we will discuss key differences between all three. After that, we are going to take a look at some of the real-world examples, and also we are going to see the sample project structures. Now, before we deep dive into the session, just a quick info guys. Simplilearn has got professional certificate program in generative AI and machine learning. You are going to learn from IIT faculty and industry experts. After that, you're going to attend master classes delivered by IIT Guwahati faculty. Also guys, you're going to experience campus immersion at IIT Guwahati. You're going to get alumni status from ENICT Academy, IIT Guwahati. So guys, hurry up now and join the course. The course link is mentioned in the description box. Now, here is a short quiz to test your knowledge. Which one of the following is mainly used to help an AI answer using external documents or knowledge sources? And your options are prompt engineering, RAG, fine-tuning, or tokenization. Please mention your answers in the comment section below. So let's get started. Now guys, let us first try to understand what is RAG. So RAG stands for Retrieval Augmented Generation. What is this guys? It is the way of making an AI model answer using external information instead of relying only what it already knows. Simple meaning, a RAG works in two steps. First, it searches relevant document or information from PDFs, databases, websites, knowledge bases, or company file. Then, what it does it generates. It uses the retrieved information to create the final answer. So instead of saying answer only from your training, RAG says first look up the right information and then answer from that. Now why RAG is so useful? So guys, if I have to say, RAG is very useful because a normal model may forget details, give outdated answer, and guess what? When it's unsure, RAG helps it because it can use the latest information, use company specific documents, and reduce hallucination. And also, it's going to give you answer from the trusted source. It's very simple. Let's take one good example. Suppose you ask to your AI systems, for example, how many casual leaves do employees get per year? Now, let's say you ask this question to your tools like ChatGPT. Normal AI model may give a generic HR answer. But with RAG, the system first check your company's HR policy document, finds for full-time employee they receive 12 casual leaves per year, for example. And then it could answer something like this, that employees receive 12 casual leaves per year. So guys, the answer is based on the document, not on guess. Let's take a real world example. For example, there is a company, let's say XYZ, and they have this HR chatbot. Imagine a company which is building an internal HR assistant. So employees ask question like, how many sick leaves do I get? Or can I carry forward casual leave? Or how do I apply for maternity leave? Or what is a notice period? Without RAG, the AI may give very generic internet style answers. It can get confused from one company policy with another, and also it may give you incorrect answer. But with RAG, the system searches the company HR policy PDF, finds the exact section which is related to the question, gives an answer based on that section, what happens behind the scenes. It uses HR policies and it stores it in a system. So let's say if the user asks, can casual leave be carried forward? Then RAG retrieves this line that casual leaves cannot be carried forward. So this is how RAG is working in our system. And that's why it is very much important in modern AI application. Now let me give you a RAG flow which will help you to understand its architecture. Suppose a user is asking a question, can a casual leave be carried forward? Now your AI model is actually searching the document or the company PDF about what is the policy or the leave policy all over there. Then that's called as the retrieval search. Now that is called as a retrieval step or the search step. It searches for the HR policy documents for the relevant information. Then it retrieves the matching policy and it says that casual leaves cannot be carried forward. Then after that there is a generation step at which it just gives you that AI has retrieved to create the final response, and this is happening internally. And finally it gives you the answer that no, the casual leaves cannot be carried forward. So this is how a RAG workflow works. Now let me also show you how will the project structure will look like. So guys, let's say inside the folder you have data, inside data you have another subfolder called raw, and let's say here you have the complete knowledge source which is company policy where you have highlighted the external information regarding what are the policies in the company. Now next up although we have the next folder which is called as processed. So let us create one more folder. Now let's say we have the next folder as processed, and inside this let's say we have a file called chunk.json. So this becomes our another file. I will explain you each one of them, what is the purpose for each of these files. Then we'll create another subfolder called as vector stores, and in this vector store we can name it as something like all over here, and inside the subfolder we can create another file which we call as FAISS, and inside this we can have another folder called SRC, which is the main folder all over here. Now inside SRC we are going to make our files, for example like loader.py, then we will make something like all over here chunker.py, next is embedder.py, then we have something called as retriever.py, then we have something called as generative.py. After this we have something called as ragpipe.py. Finally we are going to create one more subfolders, and here we can have one more file all over here. We will call it as utils.py. Now this is done. Now we will create one subfolder all over here, and we will call it as something called as prompts. And inside prompts we are going to give the respective file name all over here, and inside this we can have the files like ragprompt.txt, then next file would be app.py, and next file would be config.py. And finally we could add something called as requirement.txt to know what are the dependencies involved. So we can just name it all over here. After that we can have one environment variable file to store all our secrets, and next we can have something called as test query. So guys, this is the overall folder structure if you see for a RAG application. Now what each folder does, let me explain it to you. So if you see the /data folder all over here, this stores your document like your original files like PDFs, text file or documentation. Then you have something called as processed. So this folder contains clean text, chunks or extracted content. It is going to have the extracted content like for example HR policy PDF, company handbook, product manual or FAQ document. Then you have something called as vector store or FAISS. So this stores the embeddings and the index files. For example, FAISS index, ChromaDB, Pinecone metadata or Deviate storage. Now this is sounding a little bit technical, but this is where the system searches for relevant chunks. Then you have something called as SRC, and this contains the main RAG logic. For example, loader.py, which loads the document from files and reads the PDF, extracts the text, loads txt or docx. Then you have something called as chunk.py, which breaks large text into smaller chunks. For example, it splits every 500 words and it overlaps to 50 words. Then you have something called as embedder.py, which convert text chunks into embeddings. For example, like it is going to have OpenAI embeddings, Hugging Face embeddings, sentence transformers. Then you see some file name as retriever.py. This file finds the most relevant chunks based on user question. For example, the similarity search, top 3 matching chunks. After that, you have something called as generator.py. It sends the retrieve context plus user question to the LLM. For example, it is going to build the final prompt and also it is going to get the final answer from the model. Finally, you have this interesting file name which is called as ragpipeline.py. So this is missed. Let me create that file, pipeline.py. Now, this is a file which connects everything together. For example, here the flow is going to be something like this. So first of all, it is going to load the query. After that, it is going to retrieve the chunks. After that, it is going to generate answers. So this is the overall pipeline that is going to be present in your RAG pipeline.py. Now, any helper functions which you are going to require in this project will be present in the utils.py. For example, like let's say you have a task like cleaning text, logging, or formatting output. So for all those things, you will have those tools present all over here. Then this is one of the most important folders which is called as prompts. Now prompt stores the prompt templates. For example, all over here, let's say you're going to give it like you are a helpful assistant, answer only from the provided context. If the answer is not found, say not found in the document. So this is going to be present something like this. Now next, one of the most important file which is app.py, and this is the main entry point. It can be a CLI app, it can be a Streamlit app, it can be a Gragio app or a Fast API backend app. So this is the most entry point. Finally, you have something called as config.py, which stores configuration values. For example, like what is the model name, what is the chunk size, or it could be like the overlap and what is the vector DB path. And finally, you see there is a requirement.txt. So all the Python libraries which you'd be requiring to build the RAG application will be present in this respective file. And finally, guys, we have something called as testquery.py, which is a small script to test the RAG system with the sample question. For example, the simple workflow of the structure could be something like this. Let's say, for example, we have the document present all over here. Then it goes to the loader, it goes to the chunker, which breaks down the given text into chunks. Then it goes to the embedder, and after that, it goes to the vector store. So this is how a RAG project is going to look like. Now, let us move to the next part and try to understand something called as fine-tuning. Now guys, you can see I have opened the official documentation based on this, which is given by Google for what is prompt repeat. So guys, you can see all over here, I have opened the official Google Developers Guide where it says about fine-tuning is a way to make a pre-trained model better at specific task, format or style by training it. And further, you can provide your own examples. Now, OpenAI describes it as the base model, giving it the kinds of inputs and the outputs you expect in your application, and getting a model that performs better on those tasks. Now, Google's Vertex AI docs similarly says the same thing. It describes supervised fine-tuning as adapting model behavior with labeled dataset by adjusting the model weights. You can leave it, guys. Repeat. I know, guys, it sounds a bit technical, but let me explain you in very simple way. So guys, we all know that a large language model already knows general language patterns because it was pre-trained on a lot of data. And fine-tuning it gives it an extra round of learning on smaller and targeted dataset so that it becomes better at something specific, such as replying in your company's tone, following a fixed output format, or doing a particular classification or summarization task. Then it handles a narrow business workflow more consistently. In very easy words, you can think of it like there is a base model, which is like a smart graduate, and fine tuning is a job specific training. So the model is not learning from the scratch, it is just being made specialized. Now, what actually changes? With fine tuning, the model's internal parameters or learner behavior are adjusted based on training examples. In practice, current platforms also support lighter weight approaches such as supervised fine tunings and parameter efficient methods like LoRa or QLoRa, which are designed to adapt models more cheaply than full fine tuning. Now, guys, let's say there is a company who wants an AI assistant for customer support. So, let's say it has this AI assistant. Now, without fine tuning, the model may answer correctly sometimes, but the style may vary. Let's say, for example, one answer could be long, another could be casual, and another answer could miss out the company format. Now, with fine tuning, okay, what you can do is you can, let's say, fine tune the answers. For example, let's say if there is an input which is asked by a customer. So let's say all over here, let's say for example, let's say customers are asked, okay, for refund status, and let's say the desired output could be all over here. It could be polite, it could be short, or it could be most importantly brand aligned. So we won't miss that because while fine tuning, we have to consider these parameters. And also, it should follow the company's standard format. After such examples, the model becomes much more consistent at producing that kind of response. And this matches the common use of fine tuning for a specialized task, let's say also the kind of output style that a LLM should give, and also focusing on organization based behavior. Now, let me also compare how RAG is kind of bit different with fine tuning in this regard. So, if I have to say about this thing, then we know that RAG gives the model the right information. Repeat. So guys, based on the past example, we have got a brief idea that RAG gives the model the right information at runtime by retrieving it from the document, while fine-tuning changes how model behaves because it has been additionally trained on examples. So guys, use RAG when you need the latest or document-based knowledge, and use fine-tuning when you need consistent style, format, or task performance. Let's say you have an HR bot that must always answer in this format. So guys, let's say we have an HR bot all over here, and it must answer based in this tone. For example, like the policy answers, action employee should take, and HR contact note. Now, if you fine tune the model on many HR examples in that exact structure, it can learn to answer in that style repeatedly. But if you leave the policy changes often, you would still need a RAG or any other retrieval system for latest policy text. This is because fine tuning is better for behavior and formatting, while retrieval is better for dynamic knowledge. So, in one line, if I have to say, fine tuning means teaching a pre-trained model to behave better for your specific use case by training it on your own examples. Whereas RAG, you give your model the latest context by looking up at the knowledge sources, external databases, or APIs. So I hope so you would have got a brief idea regarding RAG and fine tuning. Now let us try to move ahead and explore prompt engineering. Now guys, I have opened the official documentation of prompt engineering. And if you are interested to learn about it, I would definitely suggest you to go through this official documentation. Now, what exactly is prompt engineering, guys? Prompt engineering is the process of designing and refining the input you give to an AI model so that it produces more useful and accurate results. So guys, now let us try to understand what exactly is prompt engineering. So I've opened the official documentation of OpenAI, and let me tell you what OpenAI says. It says that prompt engineering is a process of designing and refining the input that you give to an AI model, so it produces more useful, accurate, and well-structured output. OpenAI describes it as using strategies to improve results from prompts, and Google describes prompt design as creating prompts that elicit desired response from large language models. Now, it might sound a bit of technical, but let me explain you something. In very simple word, it means that it is basically how you ask AI. The model may be powerful, but the quality of the answer often depends on how clearly you describe the task, how much context you provide, or whether you are specifying the format or not, or whether you are including examples or parameters. These are all common prompt design and best practices. So guys, you can refer to OpenAI's prompt engineering guide, or you can refer to Google prompt design guide. So they have released their official documentation on that, and it is very helpful for you to understand. So you can see this given link all over here. It says prompt design strategies, and you are going to get Gemini API. Similarly, you can search for OpenAI prompt design strategy, and you can see they have also listed out the same thing. So if you go all over here to this documentation, you could see the respective type of a prompt, and following that, what is the generated output. Then you have the same thing, you have the partial input completion, and there are a lot of things, and I would suggest you go through it such that you get a better idea regarding the same. Now, in very simple words, first let me tell you what exactly is prompt engineering. Let's say I go to ChatGPT, and in the ChatGPT, I just give a very random question. Let's say, explain, or you can say this in simple English. And let's copy some of the technical things, like let's say, so let's try to see the documentation for low rank fine tuning algorithm. And I'm going to ask ChatGPT to actually explain this. And let me copy all of these things, and I will say this. Now it is getting uploaded, and I just give a respective prompt. Now, in very simple words, I would say that this is a very vague prompt. Now, how I can improve this is like this way. So you can say something like this: you are an AI expert, and I am referring to IBM official's documentation for LoRa, which is a fine LLM fine-tuning technique. So use the IBM information and explain with real-world example. Now you could see all over here how my prompt design has improved so much. Now I'm actually trying to give some context to our LLM, and then it is going to return the respective response. Now there are a lot of strategies how to actually improve your prompt design. So for that, I have suggested you to refer these two things. Now, similar, this kind of thing is called as prompt engineering. So you are not exactly training the model, but you are guiding it in a very proper way. Now, let me also tell you why prompt engineering matters. So guys, a well-structured prompt engineering can improve response quality, accuracy, completeness, and formatting. And prompt engineering is usually an iterative process where you test and refine prompts based on the outputs you get. So guys, what usually goes inside a good prompt? According to the prompt design guidance from OpenAI and Google, effective prompts often include clear instructions, relevant context, examples when useful, and the desired structure of the format. So here you are going to get something like as task. So in the prompt engineering, you are going to get something called as role. Then you need to give the proper task. Then you need to give the context of it. After that, you're going to define what are the constraints involved in this. And then you give a proper prompt engineering. Now, if you compare prompt engineering versus RAG versus fine-tuning, then it's very simple. You can consider prompt engineering as the instructions to improve your required response. And fine-tuning is improving models' learned behavior through additional training. So prompt engineering changes the request, not the model itself. And RAG and fine-tuning solve different problems. So in a nutshell, prompt engineering is a practice of carefully writing and refining prompts so that an AI model gives the kind of answer you want. Now guys, that was all for today's session. I hope so you would have got a brief idea regarding what is prompt engineering, what is fine-tuning, and what is RAG. And also guys, if you like these kind of videos, then I request you that do not forget to hit the notification bell icon such that you don't miss out any video from our end. Thank you guys for watching this video.